Hey y'all, welcome back to another video with me, Ms. V. I'm a geometry teacher and I am here on YouTube to teach you guys some geometry. So let's just go ahead and jump right into it. This video is going to be all about the triangle congruence. Ooh, I'm already spelling wrong. That's why I teach math. The triangle congruence theorems that we have available to us, okay? And these different triangle congruence theorems, there are 5 different ways that you can prove that 2 triangles are congruent to each other. So that's 5 different ways to prove that 2 of them are congruent to each other. And the way that we do this is we look into the relationship between the angles and the sides of the 2 different triangles, okay? So I'm going to go ahead and write all of them out real quick for you guys. And I'm going to give you an example of each one. So the first one is going to be The first one we're going to talk about is going to be SSS, or side, 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 okay? So what this means is if you have 2 triangles, let's say we have this triangle over here, ABC, and this triangle over here, DEF, and I know that all 3 sides of these triangles are congruent. So let's say I tell you AB is congruent to DE, EF is congruent to BC, and FD is congruent to CA. So since all 3 sides of those triangles are congruent to each other, I can say that the 2 triangles are congruent to each other, okay? So first you have to look at the relationship between the sides of the triangles. If all 3 sides on each triangle, so each corresponding side is congruent to the other, then you can say that those triangles are congruent, okay? So all 3 sides are congruent to each other, okay? And just to clarify, it doesn't necessarily mean that, for example, ABC, it doesn't mean that those 3 sides, AB, BC, and AC have to be the same length. Like, for example, this doesn't have to be 3 inches, 3 inches, and 3 inches. No, not like that. All it means is that if AB is 3, then DE would have to be 3. Let's say EF is 4, then BC would have to be 4. DF is 5, then AC or AC would also have to be 5, okay? So each of these sides is congruent to the other in the triangle, okay? So you're talking about 2 different triangles. That's the first one, side, side, side. We also have side, angle, side. So SAS, side, angle, side. And same idea. Well, let's do 2 triangles. And I'm going to keep using ABC and DEF. So we have triangle ABC and triangle DEF. So if I say, oh, hey, this side, the included angle, so the angle in between, that is called the included angle. And the side right next to it are congruent to this side, the included angle, and the side right next to it, then I can say that those 2 triangles are congruent to each other. So we have a side, the angle right in between, and the side right after, okay? So side, angle, side, side, angle, side, okay? The third one that we have is angle, side, angle. So ASA is angle, side, angle. And as I'm sure you can guess already, I'm going to go ahead and draw out these triangles for us. ABC and DEF. By the way, when I look down when I'm writing, it's because I write on my iPad during these videos. So that is why I'm looking down, okay? So angle, side, angle. We have an angle. This time it's the included side. So when you're talking about the side in between, it's going to be the included side. And then the angle right after that is angle, side, angle. So angle, side, angle, okay? Angle, side, angle. Fourth one, number 4, we have AAS. So angle side. Angle side. So now again, let's draw these triangles right quick. A, B, C, and D, E, F. D, E, F. So now here I'm looking at angle, side. Okay, so now it doesn't have to be the side in between like ASA. It's the angle, the other angle, and then the side right after. Okay, angle, side. Notice it can't be something like angle, and then this side over here. That doesn't count. Okay, it has to be like in that order. And this wouldn't be angle, side, angle either, because it's not the included. This side would have to be in between the two angles. So that's the side. Okay, so it's angle, side. You follow it in that exact same order. Okay. And then the very last one that we have is called HL theorem, or hypotenuse leg theorem. Okay, and this one, you just have to know that this is only for right triangles. Okay, so I'm going to write a little note here, only for right triangles. Only for right triangles, which we know is a triangle that has a right angle. Okay, so let's draw a triangle with a right angle over here. Okay, ooh, that side came out weird. There we go. Okay, we'll call this triangle ABC again. And I'm going to draw another one over here. Okay. The right angle's right there. D, E, F. Okay. So for this one, you just have to know what the hypotenuse and the leg of a right triangle is. So the hypotenuse of a right triangle is always the side that is directly across the right angle. So this is the hypotenuse right over here. Okay. And then a leg is just any of the other two sides that make up the actual right triangle. So like this is a leg and this is a leg here. Okay. So hypotenuse leg theorem just says that if the hypotenuse of both triangles and one of the legs, doesn't matter which one, if the hypotenuse and one of the legs is congruent, then those two triangles are going to be congruent. Okay. So hypotenuse leg theorem, you just need the hypotenuses, hypoteni. I don't know what the plural version of hypotenuse is. So yes, if those two hypotenuse are congruent and one of the legs of the triangles are congruent, then you can say that those two triangles are congruent. Okay. So in my next video, I'm going to go ahead and do a couple of proofs on this. I just wanted to give you guys all 5 of the triangle congruence criteria. So these are the 5 theorems that we use to prove that two triangles are congruent to each other. And in my next video, I'll go ahead and do some 2-column proofs for you guys, so you guys can see how we can use these theorems in action. Okay. So if you enjoyed this video, go ahead and subscribe to my channel so you can continue to watch some more videos. And I will see y'all in my next video. Have a great one, y'all. Be awesome and be bright. Bye.